Electromagnetic waves and the electromagnetic spectrum. Electromagnetic waves are transverse waves that travel without any medium. They can travel through empty space. They travel as vibrations in electrical and magnetic fields. They have some magnetic and some electrical properties to them. When an electric field changes, so does the magnetic field. The changing magnetic field causes the electric field to change. When one field vibrates, so does the other. This results in the formation of an electromagnetic wave. Electromagnetic waves travel very fast, around 300,000 kilometers per second, the speed of light. At this speed they can go around the world 8 times in 1 second. Electromagnetic radiation has properties of waves but also can be thought of as a stream of particles. For example, light can be a wave and at the same time a particle. Light as a wave, light behaves as a transverse wave which we can filter using polarized lenses. Light as particles or photons, when directed at a substance, light can knock electrons off of a substance, photoelectric effect. The electromagnetic spectrum is the name for the range of electromagnetic waves when placed in order of increasing frequency. Radio wave has the lowest frequency while gamma ray has the highest frequency. The different electromagnetic waves have several applications in our daily lives. It is very useful in communications, lightings, medicine, security, navigation, and other technological advancement. The first type of electromagnetic wave is the radio wave. It has the longest wavelength and lowest frequency of all the electromagnetic waves. One practical application of a radio wave is the Global Positioning Systems or GPS, which is used to measure the time it takes a radio wave to travel from several satellites to the receiver, determining the distance to each satellite. Another application of a radio wave is its application in broadcasting. Through radio waves, it is possible to transmit a message over long distances. MRI is a medical diagnostic technique that combines strong magnetic fields, radio waves, and computer technology to create images of the body using the principles of nuclear magnetic resonance. A versatile, powerful, and sensitive tool, MRI can generate thin-section computerized images of any part of the body including the heart, arteries, and veins from any angle and direction, without surgical invasion and in a relatively short period of time. MRI also creates maps of biochemical compounds within any cross-section of the human body. The next type of electromagnetic wave is the microwave. It has a frequency and shorter wavelength than the radio wave. It has also practical applications in cooking, communications, and navigation. A microwave oven is an appliance that uses electromagnetic energy to heat and cook foods. A microwave oven uses microwaves, very short radio waves commonly employed in radar and satellite communications. When concentrated within a small space, these waves efficiently heat water and other substances within foods. Radar, radio detection and ranging, is a remote detection system used to locate and identify objects. Radar signals bounce off objects in their path, and the radar system detects the echoes of signals that return. Radar can determine a number of properties of a distant object, such as its distance, speed, direction of motion, and shape. Radar can detect objects out of the range of sight and works in all weather conditions, making it a vital and versatile tool for many industries. The next type of electromagnetic wave is the infrared. Infrared radiation is the emission of energy as electromagnetic waves in the portion of the spectrum just beyond the limit of the red portion of visible radiation. The wavelengths of infrared radiation are shorter than those of radio waves and longer than those of light waves. One practical application of infrared is thermography. Thermography, in medicine, is measurement of body heat emitted by the skin. By the use of film or various viewing devices that are sensitive to infrared, thermal, or heat, radiation, thermograms, or maps, can be made of all or part of the body. It can also be used in photography and security. Light traditionally refers to the range of frequencies that can be seen by humans. Visible light is the only EM wave that can be seen by the naked eye. Visible light usually separates into several colors when it enters a prism. The colors are red, orange, yellow, green, blue, indigo and violet. Red has the longest wavelength but lowest frequency and energy, while violet has the shortest wavelength but highest frequency and energy. Visible light enables us to see things around us. It can also be used in artificial lighting such as flashlight, lamps, and others. One use of optical fibers in medicine is endoscope, a flexible tube with tiny camera that is used to observe the internal parts of the body. The next type of electromagnetic wave is ultraviolet. Ultraviolet is relating to invisible light. Ultraviolet is relating to or producing electromagnetic radiation of wavelengths from about 5 to about 400 nanometers, beyond the violet end of the visible light spectrum. Ultraviolet is not entirely harmful as it is a good source of vitamin D. It can be used in medicine, astronomy, photography, and even microscopy. X-ray is one type of electromagnetic wave that is located near the end of the electromagnetic spectrum. They carry a great amount of energy and can penetrate most matter. X-rays can be used in medicine like scanning bone fractures, treating certain diseases, notably cancer, by exposing tumors to X radiation, and locating foreign objects in the human body like objects. It can also be used in industry like checking for tiny cracks in structures in construction. Too much exposure to X-rays is detrimental to our health and may cause serious diseases like cancer. Located at the end of the electromagnetic spectrum is the gamma ray, which has the shortest wavelength but highest frequency and energy. It has the highest penetration energy. Gamma rays are very useful in medicine as it is used in treating cancer. Too much exposure to gamma ray can be harmful at the same time as it can cause cancer. Electromagnetic radiation can really affect living things and the environment. Radiation can be ionizing and non-ionizing. Non-ionizing radiation does not have enough energy to remove electrons from atoms or molecules. Radio waves, microwave, infrared, visible light and ultraviolet are non-ionizing radiation. We are exposed to low levels of non-ionizing radiation every day. When the exposure is intense and direct, it may result in damage to tissues due to heat. Right amount of non-ionizing radiation like UV rays maintain proper mechanism of ecosystem. X-rays and gamma rays have ionizing radiation. Excessive exposure to these can alter molecules within cells and may cause harm such as skin or tissue damage, cancer, and death. When handled improperly, radioactive pollution may occur, where the air, soil, and water will be contaminated. This pollution makes its way to the food chain where all forms of life may be affected. These are the negative setbacks of nuclear energy and nuclear arms.